but I kind of suspect that's not the case.
So you're saying it's more difficult if
It's more difficult.
With the ATM network?
I think it's more difficult with ATM networks.
Okay, any other opinion?
No, no experience.
It is a much harder problem transitioning from an ATM, from an IP over ATM to an IP over MPLS network. The problem is that you have then two traffic engineered underlying networks which don't know about each other. The MPLS over ATM just doesn't seem to be taking off that much. As far as I know, the implementations are just not there. So you actually have to build out two traffic engineered backbones that don't know about each other, that are carrying different subsets of your traffic. About the only way I can see where that would go smoothly is if you timed your MPLS transition at the same time that you were doing basically a massive capacity upgrade that was going to buy you the excess bandwidth to do this sloppily. And then get rid of the ATM stuff and convert your ATM links to POS at that point. But the two would have to be done at the same time.
See, I heard that Ascend has
Can I get
this...
you to loop back around so we can get the questions behind you, because I'm getting tired of looking at Avi.
Okay. One last question. I saw that Ascend has this MPLS over ATM solution. So based on what you're saying, do you think it's more difficult to deploy that?
The issue there is if you don't happen to have Ascend routers in your network and you're trying to get rid of ATM, you don't want to just buy them and then throw them away a few months later because you just use them for this transition. So if it's just a transition issue, you want to be putting something in your network that you're going to keep in your network, and more capacity is something that you're going to keep in your network, whereas ATM switches are something you're going to throw away. So the people who are doing this sort of a transition are very reluctant to buy new switches just so that they can get rid of them.
Okay, thank you.
To the best of my knowledge, what Ascend purports to be MPLS is actually what they call IP Navigator, which is to say that they actually do the one-arm router on a stick, but they stick the router on the ATM switch. So I think Ascend, Lucent, absolutely could. They're very intelligent people. They absolutely do have the capability to actually do interoperable MPLS, but to the best of my knowledge, they haven't attempted to do so, and I'm sure there's some semi-obvious reasons why.
Go, Avi.
Thank you. I, on the other hand, could never tire of looking at Ed and the fellow panelists. So, I had a comment in regards to a comment that Curtis made about traffic engineering, especially when you have fiber cuts. One of the things that some people are doing now and some people are going to be deploying as a stage between basically a pure IP network and people who are considering MPLS is using confederations as a method of doing AS-based, destination AS-based traffic engineering. So you can say, I'm going to honor meds, over these links, but if they, for certain ASs, but if they go down, you can not honor meds and just be carrying traffic over your own network. You don't get any of the number of things that you get with MPLS, like the ability to specify how big certain flows should be, or even look at how big the flows are, but it is something that people are doing. So.
I think if you take a look at any topology and you try to do simulations of how well your load balance would be after an arbitrary cut in the network with that, which is essentially an IGP-based technique, and a traffic engineer technique, is you'd find that your load balance was a lot better with the traffic engineered technique. If you sustained a substantial fiber cut and you really needed that capacity, the difference, which is quite significant, would matter. It would matter to your customers, and therefore it would matter to you. So I think you'd be better off with the MPLS. I'm not saying that you don't have a workable solution there, but I think you'd be better off with the MPLS. An issue with MPLS right now is doing MPLS across IGP boundaries, whether they're OSPF area boundaries or whether they're if you have separate IGPs. Most of the confederations that are being built today are single IGP, single area. Most of the networks that use confederations, or at least that I'm aware of. So that still remains an issue as far as I know.
For as much money as we're paying, you'd think they'd have more mics here. Arvi, are you saying that if you transition to confederations, you get better traffic engineering?
You can. It doesn't help you transition to MPLS. It's a lot more painful in some ways if you're not running confederations. There's no really elegant way to cut over. But you can use route maps at an inter-confederate sort of border, and if you actually constrain your IGP to express different policies, to say honor metrics from certain ASs, as routes come in to this confederation over these links, but not other links, so that you won't even you'll have different metrics on the routes heard via different paths.
I've been asked to ask you if you've tried this.
Yes.
Okay.
And it can work and does. But that's not necessarily good for everyone. Some networks have a lot of traffic that they use, say, to honor meds to deliver traffic to other providers, and they don't really need to be doing all that. They could just next hop into peering pipes. So you can sustain 60-80% of your bandwidth going down. And the problem being, well, when that happens, without some way to automatically reroute using MPLS or confederations with policy for traffic engineering, a human being has to go in and say, let's change all these so that we're not honoring meds, so that traffic stays local, so that we don't overwhelm our backbone.
I have this little toy simulator, and if you want, you can play with it and try. If you have enough statistics on your network, try plugging it in and see what sort of balance you get with different techniques. Mm-hmm. It'd be interesting to. I don't know how willing you are to share any of that with the broader community, but if
We're
you're
plenty
not
willing.
What?
Plenty willing.
Well, then we should get together after the meeting, and our toy simulator is available for anybody who wants to play with it.
Considering the deployment experience that you guys have had with MPLS, if you were asked to come up with a wish list for management tools for one, deploying, and secondly, troubleshooting, any comments on what you might come up with?
Well, I think we covered a lot of the wish list earlier in the presentation. One tool that hasn't been mentioned that kind of deserves a plug is something called Wandle by a fellow named Dave Wang, which is not by any stretch a real-time tool, but provides an offline simulation tool, which can be very useful for feedback and to plan changes. And it's real expensive. What? Spell check? Spell it? Wandle. W-A-N-D-L. So that's good. We actually developed sorry, I'm slow. We developed a moderately robust set of expectish scripts that'll log in, and it'd be nice if something like that were available, although I guess I don't really think it would be nice if something like that were available, because vendors are just going to make it for them and you're going to have to adapt it anyway. So it'd be nice if someone like in the IENG genre had developed a set of tools that would allow you to make reports on path routing and bandwidth computation, and how many X number of links go through a given trunk, and what's the aggregate bandwidth they consume. It doesn't match what the network tells you. That might be nice.
Yeah, I mean, a lot of the tools were either covered in the presentation or you can ask them offline because they're in our heads, but...
Exactly, I was wondering if we could hear about them, but I can ask offline. Thanks.
That's great. Hey, look, it's Bill.
Yeah, actually, I was listening to this, I'm kind of wondering myself, based on you guys' experience deploying this stuff, would you say this at this point we're sort of 100% baked, 75% baked, 50% baked in terms of being able to operationally in a turnkey way deploy this stuff? My sense is from the questions that were asked earlier, there really needs to be some work done on the interface into MPLS configurations to make this a truly easily deployable solution. I was curious if that's your sense as well.
You're adding a lot of tunnels depending upon your deployment strategy, and the management of those tunnels can get very complex. And it's a difficult thing to answer, what tools are needed, because to a lot of extent that is dependent upon your existing environment. You may be able to expand your existing configuration tools and that sort of thing to cover this very easily. You may not. For each network that you're looking at, how it's managed, that is a major component to your deployment and your plan. The code, the MPLS code works, so that's ready.
Don't confuse just standard MPLS with any constraint-based system, because all of that is, barely baked.
Right. So it really does sort of, you have to look at each environment differently and have to say, what will this scale? Will this be able to support this, and go from there?
I think that there might even be a bit of an underlying assumption here, which is that you can get this to be easy. I don't know about you all, but I'd imagine you all do fairly well financially because you're able to do things that others consider hard. So I'm not proposing any sort of collusion or anything, but I don't think that this stuff is really meant to be easy for a while. So certainly you want to make it easier, but please don't have the assumption that if you buy the right GUI from your vendor and if he tells you it's easy, it'll just be easy once it's got a GUI. And I know you don't mean that, Bill, but I think a lot of other folks sometimes have the mentality that, gosh, just give me a GUI I can point and click at so that it's easy. And I don't think that's really what the game is here. Yeah, we'll need to get there, but we're not there yet, and it'll be a little while. But does MPLS significantly decrease the reliability of an operational network today? No, I don't think so.
Any other questions? Any other questions? Well, I still have the one. How do you see the most as far as getting traffic into the various tunnels, whatever the tunnels, be it MPLS or otherwise? Just basically by source, by destination, by type of traffic. All the vendors make a big issue of latency, and I'm kind of curious as to how important you guys think latency is as far as getting that into a tunnel.
For like real time, you mean?
Yeah. I've burned them out.
So far, mostly what we've done is a destination-based thing. It'd be nice to be able to do some source-based stuff, but that's been limited so far. If you really want to go down a voice path, you're going to need, or any sort of real-time application path, you're going to need some other hooks there as well. And I think I kind of touched on some of that in my presentation.
I once told Ed I had a strong opinion about something, and he said I had strong opinions on everything. And I have a strong opinion about this, which is that today a good amount of interfaces have multiple queues, so such that one can do a low latency path. So it seems apparent to me that certainly you're going to build a forwarding equivalency class based on SPF destinations, and there Hank Smith, just Hank? Who else did that? Maybe Anchor, or anyway, Naming or someone. I think Naming and Hank Smith did a draft on the SPF forwarding topology and how it works, and that's really useful to back it up. But anyway, I think in my opinion, there's two things you need: the SPF forwarding information to form the forwarding equivalency class, and then as kind of a parallel over that, different experimental bits. So you can map your diffserv bits, if it ever works, into the proper LSP, and then you can just use that as your way. So I don't think it's source-based. I don't think it's port-based. I think that you should use source and port-based stuff to interpret a given diffserv code point, and then map different logical overlay networks inside of your topology with different permissible experimental bits into them. So you could have like LSPs this way that are low latency, and LSPs that way that are high latency, and LSPs that way that are Russian top secrets that can't go through Oklahoma or something like that.
You're assuming diffserv works.
And I'm assuming diffserv works, but this thing that I guess is not called precedence, but is 3 little bits that the vendor lets me set, allows us to do that. We just need the support inside of MPLS to say map this traffic class that is defined by a diffserv or a precedence pattern 010, map it into this LSP. that goes into low latency buffer so that all my voice over IP traffic can go there and get higher priority and also get lower latency.
Go for it.
I had a couple of questions related to the small provider network. The experience related here has mostly been large-scale networks. I wanted to hear your thoughts on deployment.
Well, I have a fairly small network in my basement. It's 12 routers.
So for a production network of, I don't know, under 100 routers. And the other question relates to any tools or projections for use of this technology across providers or within corporate networks connected to a provider. Thanks.
I don't necessarily see MPLS as going across providers. I see it basically as being with inside one IGP domain, and trying to figure out how to run it multi-provider or across IGPs is, I think, not going to scale for one, and this just gets too complicated. I view the MPLS stuff more as a, within one routing domain way of doing traffic engineering. So it's another IGP-like sort of thing that you want to deal with, not something between providers. For the size of the network, if you're talking small providers and large providers, I think one of the real reasons that you deploy this stuff is for the traffic engineering aspects of it. I have links that are overloaded. I have other links that aren't used. How do I get traffic to go? Don't all fill up this link. Use some of it. Use some of the other one. And that, whether you're a big provider or a small provider, people run into similar problems. So that's why I would probably end up using it. Does that help?
Any MPLS across providers is probably a long way out. There may be use for MPLS across providers, but it has to be done in a scalable fashion, which is basically not any way that has been discussed in the IETF so far, to pass essentially the classification of traffic if your traffic goes through multiple providers as part of the MPLS stack, but not past the path itself. This has to be done in a way that doesn't break aggregation. There's been some thought put to how to do that, but that's going to be a long way off. In the OSPF ONP draft, there's the hint of providing external information so that if somebody that you're adjacent to is a little overloaded and you couldn't care less because you're very underloaded, you might just do your customers a favor by taking the less loaded path for your neighbor. That's also, the ONP stuff isn't here yet at all, so that's also a long way off. So any use of MPLS across providers is a long way out.
I'm getting the sense then that some of you folks see the MPLS stuff being used in addition to IGP metrics or in replacement of IGP metrics.
I'd probably hack IGP metrics until I can't stand it any longer, or until it doesn't get you, and then start looking at MPLS today.
It certainly is an addition. You can't leave a static IGP topology, but I think that one of the points that needs to be addressed or reminded or highlighted, I guess, is that if you touch an IGP metric here, it's quite likely to have far-reaching implications that are somewhat difficult to model. If you change an LSP from point A to point Z, your set of affected variables is constrained, and you can determine what the effects are a lot more easily. So certainly they have to be used hand in hand. I wouldn't go so far as say we tune IGP until we can't anymore and then do constraint-based stuff, but I'd say it's a mix. It gives you another tool, which adds complexity, but gives you another tool so you can decrease utilization.
Last one in the back.
Yeah, I have two questions about the fast readout, which was mentioned by Curtis and Andrew. I would assume the fast readout, which will be faster, is because you do the RSP pre-provisioning. And if that's the case, what would be the performance ratio between using the RSP and the IGP? And the second question is, if I have to do pre-provisioning, does that mean that I have to do pre-provisioning for every single possible link failure? And if that's the case for a complex network, how possible is that?
The fast reroute stuff I've been hearing about is one when it more automatic.
Sorry, did you say you have been hearing about?
I have not used it yet. Okay. So I've been talking to the vendors about what they're looking at. The fast reroute stuff I think is going to be quite important in the future. I don't think it's here yet. Okay. That's more of a research area at this point. But the stuff that has been talked about is doing, I believe, automatic calculation at each point of alternative paths. But when you're allocating the bandwidth for those paths, you allocate it as a backup bandwidth, not as primary bandwidth, so that it has some flavor of knowing that you're not really using this bandwidth yet.
So you think they'll be faster than IGP? I mean,
well, the thing with it's they're hoping to make it faster than IGP because the path is already set up, so it knows that if this link goes down, what's the traffic? If traffic's coming in this way and the next stop is down, it already knows has an alternative path already there to go around this way. Instead of saying, okay, this link is down, re-advertising the fact the link is down and everybody else around it has to recalculate. The IGP recalculation still happens, so that the fast reroute is sort of used for a temporary hack to get around the path, and then you actually figure out what the real new topology is, and everything sort of re-sloshes around to handle it. That's the way my understanding of it works. Do you want to? Yeah.
But I guess the scalability issue is not addressed, right?
What's the question? Stability or scalability?
If I have to do pre-provisioning, that means I have to do pre-provisioning for every single possible failure in the network in order to achieve the fast reroute.
Okay, so let's talk about 3 ways that you can do restoration with an MPLS-based LSP topology. The first way is you can provision an LSP, and if it breaks, you can tell it to go find another path. Or you could tell it, never mind, you're dead, use the IGP. That's the first way. That's simple. That's not particularly reroutish. Okay? The second way you can do it is for each logical LSP, you can provision a primary path and also provision a backup path. So you can go from New York to San Francisco, the northern route, and the backup goes from New York to San Francisco, the southern route. That's the second way. The third way is what's generally, I think, called fast reroute. And to the best of my knowledge, in production deployed networks today, only the first is done. The second 2 aren't done. But the third way is that what you'll do is between 2 routers, like say for example, Chicago and Cleveland, you would protect the physical trunk with a backup LSP that would go from Chicago down to Denver and then over to Cleveland. And what you'd say is any LSPs that go through this physical trunk, that are mapped onto this physical trunk, if the trunk breaks, encapsulate them in this workaround LSP. Now this is good for a couple of reasons. First, if you think local to the ADM versus local to the router, it's really a function of observing a problem and reacting. So this is like a hardware problem. This is like something you can program on the router. It's pretty reasonable to assume that we can make routers or LSRs do restoration as fast as ADMs because it's a local hardware problem. The second benefit you get is that, hey, that guy in Chicago gets to think for himself. So he doesn't have to go all the way back to New York or all the way back to San Francisco or wherever and say, hey, we got a problem, what do you want to do? Because you've got 30 milliseconds latency back there or whatever it is. He can act on his own and route it around. So that's really the reason why folks believe that LSP fast reroute can go faster than the SONET stuff.
I agree, but since we do not know when the failure will occur, right? We don't know when the fiber will be cut. So because of that, you have to pre-provision a backup RSP for any primary RSP. And yet, you may have to provide a backup for a backup.
Well, that's a real good point, and Mr. Kern says we're out of time, so let's talk about it tonight. Oh, I'm sorry.
Well, if we have a few minutes, fast reroute. Well, actually, the restoration, as Alan pointed out, can happen in a number of different ways. And one is that you simply set up an LSP after the failure occurs. There is quite a bit of length of time there. The IGP or RSVP has to indicate back to the head end that the LSP has failed, and then you have to do all the signaling to set up a new LSP. The alternate is to provide a backup LSP. this leads to a very difficult problem, because if you provide a backup LSP and you reserve the bandwidth for the backup LSP, you now have a very hard problem laying out the network. And there's work in the academic community now to try to find optimal algorithms. They're very difficult. The other is if you do this static provisioning and you do this offline, this is head-end restoration, and we're running out of time. The other form of restoration is to do the restoration at the point of failure. And since we're running out of time, I guess I can't go into that.
Take it offline. Take it to Alan's boss tonight. I'm sure he could use the company. Real quickly, I wanted to take 30 seconds to talk about the traffic engineering working group that's now in the ITF, because I would like to have as much operational input as possible. So I wanted to take a few seconds to talk about the focus of that working group. It is about intra-AS, so doing traffic engineering just inside an AS, for doing performance optimization of true operational networks on the internet, and to control aspects pertaining to intra-domain routing and resource allocation. What's currently being worked on, or going to be worked on, is a framework document, just trying to get together all of the principles and requirements that we operators think we're going to need to do traffic engineering on the internet. So that being said, there is going to be a traffic engineering working group meeting in DC next month. Yes, it is just next month. For those interested in giving their input, I strongly suggest you read do some background reading into this draft, which goes back to Joe and some other people, Joe and Daniel, who I know Joe is here, who were mentioned earlier, and then the mailing list at the bottom. And that's pretty much it. Thank you very much.